Hello everyone, it's nice to be here and just thank you for the lovely introduction. My name is Mashhood and I am the technical lead at Recurhsip. Recurhsip is a JavaScript consultancy based here in Karachi, and essentially we are working with different startups in US and Europe, and we're helping them build their prototypes and MVPs. Other than that, we also provide consulting and training to companies in Europe and US, JavaScript related, around Angular 2 or Node.js. Today, I'm going to talk about the very language we specialize on and how it has evolved over the years, starting from its creation. So I'm pretty sure there are a few of you here who are already falling asleep and we're like, JavaScript is an outdated language, it's a dead language and nobody uses it. But it's not true, obviously. You can see here, this is a survey from last year, and you can see that JavaScript is right on the top of the curve. Essentially along right there with Java and PHP and Python. So JavaScript is a language that is being heavily used right now, and it has a very strong community, and there are a lot of people using it as of right now. Why is that? And primarily because you can run JavaScript everywhere. So everybody knows here that you can run JavaScript in the browser, and in the browser it has a massive advantage because it is the only language that can run in the browser. But even outside the browser, you can literally do anything because browsers are now everywhere. So if you wrap a browser in a desktop app, it essentially becomes a native app, and that's exactly what Electron has done. And all of you here who've used Atom or VS Code or even Slack for that matter, it's all JavaScript apps that are looking like native apps and are running natively. Of course, on the server, everybody knows it's Node.js. You can run JavaScript using that. On mobile apps, you have technologies like PhoneGap and Cordova and Ionic that are essentially doing the same thing. They're creating a wrapper around the HTML web page and then publishing that to the store. You have a database that is purely JavaScript based, so it stores data as JSON, and JSON are just native JavaScript objects. So when you're fetching or pushing data, there's no conversion in between. So just that JSON object just goes and gets stored into the database. So that makes it really fast as well. And finally, there's the whole world of IoT now. And Raspberry Pi is one of the devices that plays part, and you can run Node.js on Raspberry Pis. And there are specific new IoT devices that are based around JavaScript. And then there are other devices like your television, your smart TVs, your smart refrigerators that just support browsers, so which essentially means you can run any JavaScript app on them. Yes, and in case we're missing out something, and that's space, we can also, so people are working on creating setups to run Node.js on satellites, and you can become a space programmer as well. But essentially the point of the slide is to show that JavaScript is no longer a trivial language. It is something that is being used even for very critical objectives like space missions. So one of the things that people often tend to confuse is the mix-up, for some reason, Java and JavaScript. And why that happens, we will talk about this in a bit, but essentially I want to make clear that JavaScript has no relation to the language Java, except for the name. So going back way in the past, we can start our journey from the very first browser that was created. It's called Mosaic, and this is how it looked like. So at this point, the web was entirely static. So it was just a bunch of text and hyperlinks, and you can have a few interaction items like a text field and a button and stuff. And uh, essentially, the idea was to share information. So you just had huge pages of text, essentially, and you could just link them up and access them through and through. However, after in 1995, there was the group of engineers who created Mosaic that came together and created a new company called Netscape Communications. Netscape Communications was going to create the first browser called Netscape Navigator, and essentially that was going to be the browser for the web, and it was going to be really advanced. It's going to have a lot of cool features, including a lot of dynamic features, right? And part of that was JavaScript, which would essentially allow people to write small dynamic apps or do dynamic interactions within their web pages. The language itself was written by a developer at Netscape. His name was Brendan, and he essentially wrote this language, hopeful language, in 10 days. The reason for 10 days was because there was a very short timeline. They wanted to push something out very fast, and that this was again the reason JavaScript got its name. They were in partnerships with Oracle, with Sun Microsystems at that time, who created Java and who was promoting Java, and they wanted to run Java applets on the browser, and that was going to be the future. But at Netscape, they felt that there was another need of another language for designers and hobbyists that would be a lot simpler than Java. It would be easy to learn, and it would be less complicated. And you didn't need the applets and the whole shebang for that. So they created JavaScript to complement it. And in order to just promote the language, they used the Java name because they were in partnership with Java. They could just use the Java name, and they didn't have any problems with the trademark. And they just called it JavaScript, and both languages then could get popular. You can see from the graph in the middle that Netscape Navigator had a very good start. It shot up all the way up to 80% market share, but then it decreased very sharply as Internet Explorer came in, and that was partly because Internet Explorer was installed on the computers by default, so nobody else thought they needed Netscape, and which is why they lost all market share, and IE just simply took over by 2000s. Another interesting development the year after JavaScript was launched was ECMAScript. And ECMAScript exists till today, and that's the body essentially that decides what's going to happen in JavaScript as a language, what are the APIs, what are the new features coming in, and they essentially control all the features there. So in 1996, they created ECMAScript 1, and they were hoping that all the new browsers coming in, IE was the biggest one at the time, they would adopt the standards, and they would have a single version of JavaScript. Unfortunately, Microsoft did not follow the convention properly, and they first didn't rename the language to JScript, their version, because they were afraid they would get a copyright infringement on the name, trademark infringement, and alongside, they also changed a lot of the APIs, and that essentially we face that even today. The problem is that when you write certain apps on Java, on Chrome, for example, there is a chance that they might break on Internet Explorer or Safari because the APIs are not aligned properly. So that has been a big problem over the last few years, at least on the front end side. So JavaScript evolved consistently up till 1999, and then in 2000s, 2001, 2002, they were trying to rewrite the language completely from scratch, and they were going to call it ECMAScript 4X. Unfortunately, because of the .com bust, and there were other factors, including the fall of Netscape, that thing didn't happen. And then Brendan did try rewriting it again. They were struggling with ECMAScript and Microsoft, and nobody was trying to completely agreeing on the next stage of JavaScript. However, by 2009, they managed to standardize certain features in all the browsers, and they released that as ES5. A few years after, they released a better version of JavaScript with a lot of enhancements. Most of them were syntactical, and that was called as ES 2015 or ES6. And then last year, we had another version with some features. So now they've decided that they will release a new version every year, and that will be corresponding that year. So it's going to be ES 2015, ES 2016, and this year we're going to get ES 2017. On the top, you can see a short snippet of how the code has evolved. It's a very specific example, but you can see the slight changes. In ES5, we were basically using callbacks, and we had promises, but we weren't using them that actively. Around ES 2015, we had error functions, and we were also using promises heavily. And obviously, last year was the introduction of the await keyword, which awaits on promises, and essentially you can make your code even cleaner using that. So as time went by, there was a need to make the web pages more and more dynamic. And in 2003, there was an article that came out that introduced this idea of a single page application. And the author talked about how you could just load the application once, and then instead of reloading the page again and again, you would just be dynamically changing content where needed on the page. And that essentially led to certain developments of certain APIs in the browser. And by 2005, we had an official word for this, for the communication, and that was called AJAX. And AJAX, for those who remember, allowed us to use the HTTP request protocol and fetch data dynamically using JavaScript into the browser without actually reloading the whole page. On top, you can see the evolution of the web as per Facebook. So in 2005, when they released, you can see it was mainly static. You just had links that just went to different pages. And by 2008 and 9, you could see that they had started to make it more dynamic. There are certain sections of the page that can be edited right there, like the edit page on the edit sidebar on the left column. And by 2016, last year, you can see that almost everything on the page is dynamic now, including the chat pop-ups that come up. And you can just edit the cover right there and your profile picture and everything. It's all happening via AJAX and JavaScript. So there was another interesting development in 2009 along with the release of ES5, and that was Google brought out their own browser, Chrome. And along with Chrome, they introduced something very interesting called the V8 engine that was essentially going to run JavaScript inside of Chrome. And because V8 was open source and anybody could tinker with it, there was a group of developers that took it and they wrote an IO library around it, and they were able to run it on the server. And thus, in 2009, Node.js was born as well. As soon as Node.js came out, there was this idea of isomorphic applications that came into existence, where you could write your front-end code in JavaScript and also your back-end code in JavaScript, which also meant you could share a lot of the code base. So essentially all the models you're defining could be shared on both sides. The utilities that you're writing for formatting stuff, for calculations and stuff, that could be shared on the front end and the back end at the same time. And then over time, pure JavaScript stacks were introduced, like mean.js, and essentially the idea was, and obviously the biggest one is Meteor, that also uses JavaScript on the front end and the back end. And the idea was to, again, reuse the code as much as possible. In 2010, there was a surge of libraries that were being created, and in order to manage all those, NPM came up. Another interesting part was because the applications had now started to grow in size, because now they had AJAX and there was a lot of dynamic functionality in front. One challenge that people kept running into was just including the JavaScript into the HTML. We don't do that anymore, but they used to do it back then, and you can have 100 JavaScript script tags in your HTML at any one point. That would obviously be not only just very slow, but also just not feasible to manage over time, because you would have these weird dependencies that a file would be required before and after a certain file, and it won't work. So you'd have to go with global dependencies and stuff like that. So Recurhsip came in and solved those problems for us. It just made the whole, it essentially introduced the idea of modules in JavaScript. So from 2009 onwards, there was a significant growth in, there's a focus towards building scalable applications, and I feel a good starting point of that was in 2010 when Backbone.js came out. And Backbone.js essentially introduced a very unique concept where they essentially said that you could create a model using Backbone and it would handle the updates in the view for you. Now, this essentially meant that up till this point, people would be using jQuery or just vanilla JavaScript to update content in the front end. And the isolation for the business logic and updating the view content was very hard, because essentially they were very tightly bound. They were very tightly bound, essentially. And so Backbone just came in and said, you don't need to write that code, and we'll do that for you. So that was a major improvement in the overall development of the apps. And Backbone is still very popular today as well. The year following, Angular, that was created by Google, and Ember took that same idea from Backbone but improved it, and they introduced two-way binding. And along with that, they built frameworks around this very idea of two-way binding. They obviously gave many additional features like dependency injection, and some essentially, especially Ember gave a very good CLI at that time, which allowed you to scaffold your application really nicely. And from this point on, there was this very fast iterative development towards the frameworks, the toolings, and the libraries that were coming out. And the idea was, how can we, one, make all our applications compatible for cross-platforms, so they could run on mobile, they could run on web, they can run on anywhere we want, including televisions and refrigerators. And secondly, they were very performance-centric, so how could you improve performance? And lastly, how do you build for scale? How do you create an application that's 200,000 lines of code and it can still have more features added to it without it breaking down, without it being a big problem to serve over the web, without it crashing on the client side every time the user tries to do something. There was a major leap forward in 2013 when Facebook announced their React. React was already being used within Facebook, and which is why it got this really strong adoption from the open source community. And the difference was how React was handling a lot of the things like change detection, and the fact that it was very focused on just rendering the view like Backbone was. And it also introduced some really introduced a new concept called component-based architecture, and that essentially also caught up really fast. The year following, Vue.js came out, and that also improved on certain things. It tried making the whole development flow easier, better tooling, etc. And last year we had Angular 2 that came out. That was a complete rewrite from AngularJS. And this year the Angular 4, the fourth version came out, and essentially now it's named Angular, just Angular. And there has been a progress, and I feel that React and Angular and Vue.js are now at a level where you can create really, really big apps with an immense amount of stability. Yeah, I mean, these can be as good as the apps that are running on your desktop application, essentially. So a few of the concepts that are now available nowadays, the biggest one being the component-based architecture. So you can see from the diagram on the right that essentially the idea is that instead of thinking of your application in terms of just controllers and views, you take each view and you break it down into small reusable components. And you have certain wrapper components that are essentially controlling the components inside them. So your app, for example, will control the nav bar, and the components themselves can be of two types. You can have a dumb component that just takes a certain input. It can take certain parameters, certain objects, and render them out, and they can submit back behaviors like clicks and change input or whatever you want. And then there are these wrapper components that essentially control all the logic that's coming in and out of these view components. This component stuff has essentially allowed us, again, it's being focused on scale, so you can reuse all these components. That means smaller code bases, and I think a bigger use is that you can essentially test these very effectively because they're very small components, and you can isolate them and you can test them, and that has been a major help in developing big scale applications. Another very important concept that has come up is TypeScript. TypeScript is a language that was created by Microsoft, and that is essentially a language that gets transpiled to JavaScript. Now, there were languages like this before. The most popular one was CoffeeScript, and a lot of people didn't like CoffeeScript primarily because it was doing too much under the hood, and even though it was optimizing really well and doing everything very, very nicely, people did eventually run into problems when using CoffeeScript. So there is a level of skepticism with TypeScript as well, but the awesome part about TypeScript is that it is essentially the same thing as ES6 or ES7 JavaScript. And the only thing it adds, only significant thing it adds is types. And if you're talking about big scalable applications, like if you're talking about a code base that's 100,000 lines of code, you need to have some static compiling. You need to have some static analysis using types so that you can find your errors properly, you can debug properly. And essentially that is where TypeScript comes in and helps out. And just last week, there was this article that I've linked on the top left that was from Slack, and how Slack has now adopted TypeScript, and they found that they had so many small issues within their code base that they're now fixed because they're using types everywhere. RxJS is reactive extensions for JavaScript, and this is a library that has come out, created by Netflix, and it's being used by Angular framework. And the idea behind it is very simple. It introduces this type called observables to the JavaScript environment, and essentially their observables are very similar to promises. So for any synchronous task, you can create an observable and you can subscribe to it, and whenever that task is done, the subscription method will be called. However, observables are a lot more powerful because unlike promises, which can only return one value, observables can return multiple values. So they're handled like streams, right? And another very powerful feature in observables is that they can be cancelled. So they become very ideal for issue peer requests, especially when you're doing something like an autocomplete, right? So you want to cancel the previous request, and you can cancel an observable using that. And then there are many other features within observables. There are many useful functions that you can use to make your code read better, and you can add a lot of complexity by just calling these simple functions. A good example is, again, given on the right side of the slide, and what we have here is an example from the autocomplete. And autocompletes are usually tricky because they have all these edge cases where you want to have a certain length of the text before you can start sending the search request. You want to wait for a certain period before you send it. So it's functions like debounce and filter just help you do all that. The awesome thing about RxJS is it's just a JavaScript library. It's got nothing to do with Angular or any of the framework. So even if you're not using any framework, you're just using JavaScript, you can just drop this in and start using it. So it's really awesome. Another cool concept to come out of Facebook is Redux, and Redux is essentially another architecture level design that you can use for your front-end applications. Um, it reduces this idea of a global state and a unidirectional flow of data. So on the diagram on the left, you can see that the UI triggers actions that are essentially actions that can be like fetch data or update something or increment something. And these are sent to these functions called reducers. Reducers are pure functions that essentially do that specific change into that store, right? So if I'm adding a new user, they will add that one user to the store. The store will then update the state of the application, and that will pass it back to the view that will then update using the state as well. So Angular came up with its own version, and that's NGRX. That's very similar. It's exactly the same thing as Redux, but we're using observables. So we can subscribe to these observables and detect changes and update our view, essentially. My personal favorite thing about Redux is that it encourages immutability, which obviously enhances overall performance in your front-end application. So there's a lot more awesome stuff to come in the coming years. Obviously, every year, JavaScript is going to come up with a new version. This year, we are going to get ES 2017 or ES 8. We have also started seeing the rise of the progressive web applications, and these will counter the hybrid mobile apps that we have today. The idea behind progressive web applications is that they're using the service workers essentially to download all the HTML, CSS, and JavaScript to the device. So, and another cool feature that they do is they add the shortcut to the homepage. So when you launch the app from the homepage, it opens like a native app, full screen. There's no browser or anything. So it's inside the browser, but there's no address bar on top. So it feels like a native app. And you also get access to stuff like the file system API and notification API. So it's under progress, but it looks very promising, especially for the hybrid apps that are usually out there. So you can essentially write a complete web mobile app and push it just using your web technology, and can get installed like a native app on mobile. Another interesting concept around JavaScript is the web components that are coming up, and essentially they will allow us to include predefined components inside HTML and just use them, which is going to be pretty awesome. So essentially the idea here is, instead of having everybody including their own version of autocomplete libraries, they could just be part of the browser, and you can just import them in and you can just use them. And so essentially it just reduces the overall overhead of the thing. So they're also like, you can create native elements using web components, and instead of something having like a section, you can have an autocomplete tag, and you can just use that in your HTML. GraphQL is again a very cool technology that's again coming out of Facebook, and these guys are essentially trying to manipulate your database using the front end. So this is a bit like Meteor, but not exactly. GraphQL is a middleware between your database and your client app, and essentially exposes this API that allows you to construct your query and manage your models on the front end. So this is very powerful because it also gives you this ability to version things in a specific way, and so it enhances the backward compatibility, and also gives you the immense flexibility of querying and structuring data on the client side. Finally, there is this idea that JavaScript may not be the future of the web, and for that they're working on technologies that can run bytecode inside the browser. And this is currently in a demo state right now, and this is being focused around gaming at the moment, but essentially they want the ability to have certain libraries or even full applications that can be compiled to bytecode, and then they can be shipped to the browser, and they can run within the browser, and they can access the lower level of the machine that you're using, so the GPU and stuff like that. So that will give it native-like performance inside your browser, and that's really, really powerful. So that's something that's being worked on, and it looks really exciting, but I guess in a few years we'll really see how it starts taking shape when it comes out. Cool. That was about it from me. In case you guys have any questions about JavaScript, my details are out there. Just you can send me a tweet or an email. And also to mention, for those who are interested in Angular itself, we have started NG Pakistan as a meetup, and we have a meetup that's scheduled this month, and hopefully in the coming months we'll have others scheduled. So do check us out on Facebook, and yeah, I'm looking forward to seeing you all there. Thank you.